news. There's no bad news. The good news is you've already done this. It's all good news because you've already done it. And yes, it's been on every exam, just like focus and directrix has been. So has this circle stuff. But the funny thing is, and I can't figure it out, is the circle question has always been on your geometry exam too. So why they're testing it in both places, I don't know. But we're going to review it just in case. Now that you know a little bit more, though, about the parabola format, I am going to talk about HK in this sense, right? HK in the parabola format means vertex. HK in the circle format means the center, okay? The other thing is, back to kind of what Tori was just talking about, when they're in parentheses like this with their X and Y, respectively, we always take the opposite sign that we see, right? So when she kind of coincidentally or accidentally got the right vertex on that one, there was some truth to that, because when you're in parentheses with the variable, it's the opposite sign that you see. And so even though you see negative h and you see negative k in the format, hk is actually your center, and that is stated right there. So, and then it equals r squared, which is your radius squared. So the first multiple choice, very straightforward. Take a minute. Raise your hand, well, not raise your hand, but be ready to hold up 1, 2, 3, or 4, depending on your choice. We're looking for a center of negative 3, 6, and a radius of 3. Okay, on the count of 3, hold up 1, 2, 3, 4. 1, 2, 3, go. I see mostly 2s and a few 3s. So 2, I didn't even look. 2, I hope is correct. Right, x minus negative 3 is x plus 3 squared, y minus 6, and then the radius squared, 9. Why did I see a couple 3s? Maybe I was not seeing clearly. The same? Opposite, and the radius is not right either. I guess I would have expected to see more of that, but anyway. All right, so you've seen this before, yes? Nothing new? Okay. Maggie, what's the center of this circle? Just jump down to B. I'm not going to do all of these. And the radius? Very good. Jump to E. What's the center of that one, do you think, Lucy? If it was 1, it would be x minus 1 squared. What's the only number that you wouldn't have to see, right? So it's 0, 3. Does that make sense? Everybody else? Okay. 0, 3, and Lucy, the radius? Very good. On I is the last one I want to look at. What is your center, Gracie? 0, 0, and your radius? Neither do I know an exact number. Well, I do know an exact number. It's just not a whole number, right? How did we get, Gracie, how did we get from 49 to 7? Right, same from 4 to 2. So same for 57. We'll just say root 57. So that would be the exact answer. If you were ever asked to round that to the nearest tenth, you definitely need your calculator, okay? On the bottom here, we're asked to write the equations of our circles. So let's start with circle A. Oh, yeah, the distance formula, right? The center is no problem. That's given to us. So what does the start of your circle equation look like? Val. Keep going. Perfect. Equals an r squared we need. Now, raise your hand if you remember the distance formula. Okay, so the reality is you're probably not going to remember it on Regents. Is it on the reference table? Yes. Oh, it is? I'm checking. I'm going to teach you how you should know how to find the distance anyway. Raise your hand if you know the Pythagorean theorem. Yeah, that's so much easier, right? Everyone remembers that one. Okay, well, that's where the distance formula comes from. If I want this distance, this is like the hypotenuse of a right triangle. So if I draw in two of the other two legs, you can sort of count. How long is this leg if it goes from 4, 1 over to 6, 4? How long is this leg? 2. From 4 to 6 is 2. How long is this leg? 3. From a y-coordinate of 1 to y-coordinate of 4, so that's 3. So now could you all find the distance just by doing a squared plus b squared equals c squared? Isn't that genius? 2 squared plus 3 squared equals hypotenuse squared. That's 4 plus 9 is 13 equals h squared. Square root of both sides. H equals root 13. So that's the distance. That's the radius, root 13. So what do I put here? It's r squared. It's root 13 squared, right? This length that we just found, root 13, is our r. R is root 13. Squared just makes it 13. Do you follow that? The formula says it equals r squared. Our r value already had a square root on it, so we squared it to get r squared. Yes? Okay. On B, Hannah, can you give me the first part of the circle formula? Keep going. Yep. Yep, just make sure you put the squares on that, which maybe you wrote but just didn't say. Okay, and then again here, to find the radius, draw it in, create a right triangle, take a minute to find the lengths of the legs. Lily, how long was this base leg here? See how we're tracing along the x-axis here, kind of parallel to the x-axis? Then look at your x-coordinates. If one starts at -2 and the other ends at 1, how long is that? 3. And if you're looking at the vertical leg, do the same thing with your vertical change, which is your y-coordinates, 4. Without doing the Pythagorean theorem, you should be able to tell me this is a 3, 4, 5 triangle. So that's 5. So what is this here? 25. Now, because we're done with that, I'll show you and remind you what the distance formula is. That's the distance formula. But we don't even need it. Reference sheet? Good, because it shouldn't be. You don't even need it. You just need the Pythagorean theorem, which pathetically is on the reference sheet, I believe. And no one ever needs to look at it to find that out. But anyway, we all know the Pythagorean theorem by heart. Flip it over. This is the real skill. This is what will be on your regents. And this is what was on your regents in geometry. But it's really no different here. I'm going to maybe try to teach you to do it a little bit more concisely, but it requires completing the square. Okay? So first things first, you cannot have coefficients on your x squared and your y squared. And luckily here we do not have that. So we're just going to kind of group your x's together and tell me, just with those two terms, x squared plus 10x, what is the magic number I'll have to add to complete the square? Let me give you a second to think about it. What do I add to make that into the perfect square trinomial? Kelly? 25 is correct. Nice job. How'd you get it? Half of b, half of 10 is 5, and squaring it. So she's adding 25 there, so add 25 to the right. Now, before moving on, that trinomial gets factored into what squared? X plus 5. Very good. Now, the next trinomial that we have to complete is the y section. Take a minute, think of what the magic number is that we need to add in there to complete that trinomial. I'm gonna go with San Rufino. Very good. Add 1 on the left, add 1 on the right, and now that trinomial factors into, there's a plus sign in between, factors into what squared? Christina? Not y plus 1, y minus 1, because the middle term is negative 2, b is negative 2, so you always just take half of that, negative 1. So y minus 1 equals. And now this right-hand side becomes 36. And now, identifying the center and the radius is easy. Gracie. Very good. Nice. Wait a minute. The next one has coefficients. I don't want you to miss that. In fact, I want you to teach everyone how to do it when there is a coefficient. Wait, we just did it the other day. Okay. So if we want to complete the square on this piece, what do we have to do first? Not divide by 4, but factor out a 4. We don't want the 4 to disappear. Yes? So it's going to be 4 parentheses x squared minus 6x, and then I'm going to leave a little space. Okay? What's the magic? Actually, you know what? Let's just sort of plus. But remember, there was a tricky little thing that came up when there was a GCF. I also have to factor 4 out of the second one. 18. Oh, it's not y squared. It's, oh yeah, it is. Equals 76. So I've just factored out the coefficient of the x for the x terms and the coefficient of y squared on the y terms. So you're going to see the parallel with what we did the other day. Obviously, what do I add in here? 9, right? Half of b squared is 9. What did I really add, though? Because there's a coefficient, I really added 36. So I really have to add 36 to the right. And what goes in here? 81. So what did I really add? 324. So to counter that, I have to add 324 to the right. Any questions on that? I know that was a little confusing for some people the other day. Hopefully it becomes clearer as you see it in different contexts. So now what does this trinomial factor into, Tori? Why do you sound unsure? What was half of b? So then did you pick the right one? Yes. And on the second trinomial, what does this guy factor into, Mike? Y. But I know what you meant. Equals, and then what giant number is all that nonsense? 436, so being a multiple choice. What happened? True. True. And you know what? Wouldn't matter though because they all have the same center anyway. So really the only thing that is different about all those is the 436. Quick question for you. If we had divided both sides by 4 from the start, we would have gotten this. Don't move, Brayden. Okay. Divide by 4, you get 109. What's the difference between this circle and then one that's been multiplied by 4? Yeah, but think transformations. They're both centered at 3, -9. So, perfect. So here's the traditional one with just a whatever radius it has. Then if you multiply it by 4, everything by 4, it just got 4 times as huge. Make sense? So there is a transformation wrapped up in there somewhere. Braden, I can't let you go yet. This next one is equally as important. I know it's not on your paper, but you have to write it down. Then, Braden, you can go.
Wait, where are you going?
Okay. The mom of a 2-year-old in me. Never mind. Never mind. No. As promised, every new type of function we've done, and so far we've only done linear and quadratic. This isn't even a function, but it still applies with circles. There will be systems expected of you to be able to solve a system with a linear and something else. So this one happens to be a linear with a circle. These always start by solving for a variable in the linear problem. So in the linear equation, pick a variable to solve for. Now here, it doesn't matter. They're both equally as simple to solve for. So, shot in the dark, Mitch, which one do you want to solve for? Let's go with x. So add 2y over. Divide by 2. Brock, you don't need to keep looking up at the board. You know how to solve for x, right? Don't worry, Brock's not the only one. I just saw him out of the corner. I saw his head out of the corner of my eye go up, down, up, down, up, down. You all do it. Even though you could do it yourself and then look up quick just to make sure you did it right, you just copy. Which is fine. It's just not as mentally engaging. Okay, so now once we solve for a variable, from the second equation we solve for a variable, what do we do with that? Plug it in. Plug what in for what? Plug in 3 plus y for x in the other equation. So that's going to be 3 plus y minus 5 squared, and the rest is the same. Simplify. Agreed? Why would we leave the 3 and the minus 5? Wouldn't we combine like terms and make that y minus 2? Everybody agree with that? So we're just combining like terms. So what variable are we solving for first? Clearly. Y. So when we get an answer, that's just the y coordinate answer. How do you solve this? What's your gut tell you? Given that you probably don't know for sure because you've never seen something like this before, but what's that? No, I don't think I know what you're saying. You can't combine them because they're different binomials inside. You literally just have to square them out. So this one, when you do y minus 2 times y minus 2, you're going to get y squared minus 4y plus 4. Right? For those of you who like to expand it and see, when you FOIL, you'll get that after you FOIL and combine like terms. Who knows the shortcut? What am I going to get when I square the second one? Y squared plus 4y plus 4, good. This is the square the first term, square the last term, and then multiply them together and double to get the middle term. Now, what kind of equation is this? Is it a linear equation? No. It's a what? Quadratic, because we have y squared. So we need to get it equal to 0. So I'm going to subtract this 16 over, and while I'm at it, I'm going to combine like terms. So how many y squared do I have? So 2y squared, how many y's? None, that's nice. So 2y squared, the negative 4y, positive 4y cancel, plus, minus, what's my constant? 8 minus the 16 that I brought over. Negative 8 equals 0. Now, if, and it's a big if because I would never do this, but if we solve this using the quadratic formula, what would our a value be? What would our b value be? A would be 2, b would be 0, we have 0 y's, and c would be negative 8. if I was solving it by factoring, which I would never do, what would I have to do first to factor this? Not divide by 2, factor out a 2. And then this is the difference of perfect squares, y plus 2, y minus 2. And then you'd tee it up and you'd get your answers. But I don't have to do either one of those because I don't have that y term, I can just get y all by itself, right? Add 8 to both sides. Divide by 2, so y squared equals 4. And then what do I do to both sides? And anytime I take the square root of both sides, I have to remember the plus or minus 2. Hence the same plus or minus 2 that would come up if I did your recommendation, by the way. Yeah. I did right nicely. Plus or minus 2 is what I would have gotten if I teed this up anyway. Y equals plus or minus 2 because I didn't forget my plus or minus sign. Am I done? No. Why not? Right. Those are only my y coordinates. So if I go over here just for space, my y coordinate, I have a y coordinate of 2 and I have a y coordinate of negative 2. I have to find the x coordinates that go along with that. And I get that how? Plugging them in. You can plug into either one of the originals, but if you've already solved for a variable, you're best off plugging into that equation. So plugging in a y of 2, 3 plus 2 is an x of 5. Plugging in a y of negative 2, 3 plus negative 2 is an x of 1. Okay, really quickly for your visual, we have a circle centered where? You can go now, Brayden. 5, negative 2 with a radius of? Radius of what? 4. So if that's my center, the way I graph a circle is just I go 1, 2, 3, 4 above, 4 to the right, 4 to the left, and 4 down, and then it's pretty much going to be a sketch from there. So there's my circle. My line, you don't usually graph lines from this format, do you? What do you solve for? So y equals x minus 3. Is that fair? What's the y-intercept? Negative 3. And what's the slope? Up 1 over 1, up 1 over 1, up 1 over 1. And do you see how the line is going through the circle twice? Hence our 2 points as our solutions. What are some other possibilities? If you have a line in a circle, they could also intersect how many times? Infinite? Could never have an infinite one. Can cross once. It can right here, right? And that would happen if you just had like a quadratic that had one solution, right? And then it could also cross it not at all. And in that case, your quadratic would end up giving you no solution, like the square root of a negative number would come up and it would have no real number solution. Do you remember those scenarios for quadratics? Getting 2 solutions versus 1 solution versus no solutions? You don't? What do you know about a parabola that has 2 solutions? Where are the solutions when you graph it? Right. So if something has 2 solutions, it has 2 x-intercepts. If it has 1 solution, it has 1 x-intercept, right? It just hits it and comes off. And if it has no solutions, then it has it none. You don't remember that? Now do you? Yeah. So we're going to talk more about 2 solutions, 1 solution, no solutions, which plays its part, obviously, for the parabola and where its roots are, but it comes up over and over again when you think about how many times a line can intersect different shapes. Okay? So